Excel Geometry. What we're going to be doing today is we are going to be learning about finding segment lengths in circles. And what we're looking at here is 10.6. So you could have either printed out your 10.6 note sheet, or you can just copy this down right in a notebook or on a loose leaf sheet of paper. I do urge you to open the document so when we do the practice problems on the back that you have a diagram to look at as you're doing them. So right now what we're going to do is we're actually, instead of looking at how chords, secants, and tangents change the angles formed, we're going to be looking at how the segments are affected. So that's what we're going to be looking at today. So we're going to be first looking at segments of a chord theorem. Now that means when we talk about this, it actually has two intersecting chords. So for example, you'll have one chord AB, and you'll have another chord, say CD. Now, we take a look at this. These two chords intersect. So if I look at this and I have CD, so these two chords intersect. And they intersect at this point here, and we're going to label that point E. All right? And when we take a look at that, when two chords intersect, they make four segments: AE, EC, EB, and ED. We have four different segments. And how are the lengths of those segments related? Well, if you have two chords that intersect in the interior of a circle, meaning not on the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So what does that mean? What this means in this theorem is one chord is AB. The product means we multiply. So what it's saying here is that AE times EB, the two segments that make up the one chord, the product of those two segments would be equivalent to the product of the two segments that make up the second chord. Well, if I look at my second chord, DC, the two segments that make up that chord would be DE times EC. That's what the segments of a chord theorem states. If two chords intersect inside the circle, then the product of the two segments of one chord is equivalent to the product of the two segments of the other chord. So that is our formula for the segments of a chord's theorem. All right, guys, segments of a chord's theorem. Now let's take a look at our next thing. The next thing we're talking about is called tangents and secants. Now, in tangents and secants, there can be tangent segments and secant segments. And I want to make sure that we understand the difference and what an external segment is. So a secant segment is a segment that contains a chord. So if I was to look at this, a secant segment is a secant is a segment that contains a chord. And I think we went over this before we left, but we want to just emphasize this again before we move on. So that's my that's a secant segment, meaning if I take a look at this, I can draw a secant segment. This would be an example of a secant segment, because if I take a look at this, this whole thing would be my secant segment. Right here, if I had this RS, say this is T, RS would be a chord. So I can look at this and say TS is a secant segment. When I also look at that, I know that RS is a chord. And I can also label something else I want to talk about. TR is outside the circle, so that is called an external segment. Now, how does that differ from our tangent segment? Now, our tangent segment is kind of external because it's always outside our circle. But an example of a tangent segment would be if I put a U here. TU would be a tangent segment. So a tangent segment has one endpoint as a point of tangency. So a tangent segment is an external segment where one endpoint is the point of tangency. So in that case, if I looked at that tangent segment, my tangent segment would be TU, and I would label that a tangent segment. It's external because the entire segment is outside of my circle, and U is a point of tangency, so that would make that a tangent segment. It's important we just know the difference in them as we go on to our next two theorems. Now, our next theorem says segments of secant theorem. So we're looking at two secant segments. So meaning that both segments would have to have a chord. They would have to contain a chord. So these would be two secant segments. So right now in this case we have two secant segments. And that's important for us to be aware. So we have two secant segments in this theorem. And the theorem states if you have two secant segments that share a common endpoint. So this in this case would be my common endpoint. That's what we're looking at there. And let's give some letters. Let's say A, B, C, D, and that common external point will be E. All right? The product of the lengths of one secant segment and its external segment. Now let's think about that. One secant segment would be EB. Its external segment would be EA. So it's saying that the product of the lengths of one secant segment and its external segment, so we're going to say EB times EA will equal the product of the length of the other secant segment and its external segment. So if I look at my other secant segment, I'm saying ED, and its external segment would be EC. So I'm saying that EB times EA is equivalent to the product of ED, my other secant segment, times its external segment. All right? So that is how we would find the lengths when we're dealing with segments that are formed by two secant segments that share a common endpoint, which is a common external endpoint. All right? That's the key thing. It has to be a common endpoint, and it has to be an external endpoint. Common external endpoint. So let me add that there too. All right, guys? Now, the last thing we're going to look at is segments of secants and tangents theorem. Now, this one is slightly different because it's going to have one secant and one tangent. So I can draw, let me just make sure you guys can see, yeah, one secant and then one tangent. So by doing this, and E is my external point, they meet at an external point. This will be C and this will be D. All right, so if we take a look at this, we have, let's just go by our vocabulary here. We have EA is my tangent. ED is my secant segment, and EC is going to be an external segment of that secant segment. So let's take a look. If a secant segment and a tangent segment share an endpoint outside the circle, so this is a common external endpoint. That's what they're sharing. Now, if they share that, the product of the length of the secant segment, which is ED, the secant segment times the external segment, which is EC, would equal the tangent segment squared. So it would be EA squared. So that is how the segments formed by a secant segment and a tangent segment, when they meet in a common external endpoint, that is how they relate. All right, guys, so now what I'm going to do is I'm going to flip this over, all right? And we have some practice problems that we're going to work on together because I know this is a new concept, so let me just check that we can see. All right, guys, so let's take a look. We're going to start with number 1. And I don't know if you want to take a look at your, what's it called? Your document if you didn't print it out, just so you can get a better idea. So if I take a look at number 1, the first thing that I notice is that I'm dealing with 2 secant segments. So if I'm dealing with 2 secant segments, the relationship will look, so this is one secant segment, and there's another. All right, and the other thing we're looking at is I have my 2 external segments. So what we said in this case is the product of the secant segment times the external segment. You have to find the length of that secant segment. That's what's important first, because they're saying this is 9 and this is 6. The length of that secant segment is going to be 15. The length of our other secant segment will be x plus 5. So if you take a look at that, what we're going to do now is we're going to multiply the external segment times the secant segment. So you can say my secant segment is 15, and I'm going to multiply it by 6. And that's going to be equal to my secant segment, which is x plus 5. And when it's a binomial, you put it in parentheses. And then we have x plus 5, and we're going to multiply it by our external segment, which is 5. So let's take a look at that. Now, if I take a look at that, 15 times 6, we have that's going to be 90. Be careful on the other side. We have to distribute that 5. So you're getting 5x plus 25. Now we're going to subtract that 25 from the 90, and I'm going to get 65 equals 5x. And what I can do now is once I get there, I can divide by 5, and I'm going to get x to equal 13. That would be my solution if I'm solving for the variable x. Okay, guys, now what I'm going to do is I'm going to do this one, number 2. And with number 2, what I notice is I have the intersection of 2 chords. So I'm going to go to that intersection of 2 chords theorem. I have one chord in yellow here, and then I have another chord in purple. And what this theorem stated is if 2 chords intersect inside a circle, then the product of the lengths of one segment of one chord is equal to the product of the lengths of the other segments of the other chord. So that means what they're saying here is that x times 3, which is 3x, the 2 segments in one chord, x and 3 are the 2 segments formed by one chord, is equivalent to the product of the 2 segments in the other chord. So 4 and 6, so that would be 4 times 6. So that intersection point is the breaking point. It breaks both chords up. So this breaks our x and our 3 in the yellow segment, our yellow chord, and the point of intersection breaks the 4 and the 6 in my purple one. So I'm getting 3x is equivalent to 24, and then x would be equivalent to 8. Okay. Now let's take a look at number 3. Number 3, it looks very, gotta look very close. This is again 2 secant segments. I have 2 secant segments, and then I have these 2 external segments. So it's the same concept as number 1. I have to find the length of the entire secant segment. So that means I look at this, and if I have to find that length, I have 3 plus x plus 2. So that would be x plus 5. Now if I take a look at my next one, same thing. I have to add the length. I have x plus 1 plus x minus 1. Well, x plus x would be 2x. Positive 1 minus 1 would cancel to 0. So the length of that secant would be 2x. Now the rule says the product of the secant segment and its external segment, if they meet at a common endpoint, would be equivalent to the product of the other secant segment times its external segment. So let's take a look at this. That means 3 is my external times the secant segment of x plus 5 would have to equal x plus 1, which is my external segment, times the secant segment of 2x. Now, be careful, we have to distribute. If I distribute here, I multiply both x and 5 by 3. I'm getting 3x plus 15 equals 2x squared, and then 2x plus 1 is 2x. Now, because I have a squared, I need to bring everything to one side. So if I take a look at that, I'm going to bring everything to keep my 2x squared positive. I have 0, 2x squared. I'm subtracting 3x, so 2x minus 3x is a negative x, and a minus 15. Now this is back to a factoring problem. So let's take a look, guys. So if I have 0, if I factor this, I have to have a 2x, and I have to have an x. And for some reason, the combination, when I FOIL 2x times my last term and my inner two terms, the combination has to be negative 1. So if I take a look at this, I can put a negative 3 here and a positive 5. And you would get 2x squared minus 6x plus 5x, which would be the same as negative x, and 5 times negative 3 is negative 15. That's how I can factor. Now, if I solved both of these, I set both of them equal to 0, I would have 2x plus 5 equals 0, and x minus 3 equals 0. Now, if you look at that, guys, I'm just going to bring it up here. I would get x is a negative 5 halves, and x is a positive 3. Let me move it over so you can see. All right, guys, x isn't, so you can see, positive 3. Now, one of them I'd have to get rid of. X can't be negative because I would have a negative length. So my only solution to this problem would be x equals 3. All right, guys, let's take a look at our next one, 4. Now, 4 is a little different because in 4 we have a secant segment and a tangent segment. Here's my secant segment, and this is its external segment. And then here is my tangent segment. Now, if we took a look at that rule, the rule states the entire secant segment, which in this case would be 4, times the external segment, which is 1, would have to equal the tangent segment squared, which would be x squared. So right here we get 4 is x squared, and what would our x value have to be? 2. I can ignore the negative 2 because, again, a length cannot be negative in geometry. Now let's look here, same thing. We have a tangent segment of 7. I have a secant segment and an external segment. Now again, once you see a secant segment, make sure you know the entire length. What is the length of my secant segment? It's 5 plus x. That's 7. So now our rule is secant segment times external segment has to equal tangent segment squared. So if I take a look at this, I distribute this 5. I'm getting 25 plus 5x equals 49. Now I'm going to subtract that 25. I'm going to get a 24. And then x will just be 24 over 25. And that would be my solution. All right? What I would like you guys to do now is try 6, 7, 8, and 9 on your own. And then I will post the answers so you can check your work. I will post this whole, actually, the whole note sheet and the sheet below. So you can check your work, and then I would like you to go and do your Canvas quiz as your attendance for the day, and then you have your homework problems. Your Chapter 10 test is scheduled for Wednesday now. You will have actually from 8 in the morning to 8 at night to complete it. But the reason I put it Wednesday is because we removed 10.7. We're going to do that as a separate quiz. So it's only going to be 10.1 to 10.6. This is 10.6, the last piece of information we have today. I will throw you a little review homework tomorrow, and we're also going to review a little more factoring tomorrow, and then the test Wednesday, and then we're going to move on to 10.7 on Thursday. All right, if you have questions or concerns, please visit my office hours on Campus Conference, or please shoot me an email. Your test has to be uploaded to Canvas, so if you're having any difficulty doing that, please contact me so I can assist you. All right, guys, I hope you have a great day, and check all the answers to these practice problems, and please visit me during Canvas Conference. All right, guys, talk to you soon.